Here's the Cartwright version of the solubility rules. In your textbook, it's like a full page of stuff. Impossible to cope with. So, these are the simplified rules. This semester in 1411, I supply them. If you come to chemistry camp in the summer, or if you take 1412, you're eventually going to have to know these to handle them. But the simplified solubility rules for salts in water. If your salt contains sodium ion, potassium ion, actually any of the 1A metals, ammonium ion, nitrate ion, or acetate, the salt will be soluble. Okay, so right away, I know that's soluble. Rule 1, it's got a sodium. It also has a nitrate. Bingo, it's going to be soluble. Okay, rule 2. All chlorides are soluble except the magic 3. And if you think about it, if you did lab 12, those are the 3 metals that you tested for in lab 12. How did you separate them out from the water? You put in chloride. They came out as their chlorides. That was that big white precipitate. Every other chloride is soluble. Then we are going to treat, this is the garbage rule. Anything else that shows up, we're going to say it's insoluble. Now, that's not going to be right 100% of the time, but it's going to be right 90% of the time. That's good enough for A work. So it's pointless to follow the whole page of stuff to get the other 10%. So, using that, once again, if you got lost in all that discussion, for a double displacement to go, you got to have a driving force. One of the driving forces is, one of these things you make is insoluble in water. See, it comes out, precipitates out, and that's the driving force to make it go to the right. So solubility is going to start showing up in here. Okay? So double displacement, you predict products and you decide if it's going to go, just as you did for single displacement. Okay, now let's look at this one. This one's kind of tricky. It was in the text and I thought I'll bring it out because it's similar to something you've seen, but you haven't seen exactly the same. If I said, this one, that one is one of the 4. Can anybody categorize it? It's one of the 4. Okay? Multiple choice. Is it combination? No. No. Is it decomposition? No. Single displacement. Now, why I'm throwing you a curve here is because every other single displacement you have seen went back to that activity series and you were kicking out the positive part. And that activity series is for kicking out the positive part. But look, it follows single displacement. You have an element. Granted, it's diatomic, but no big deal. That's the way it's going to be. Diatomic, element. You've got a compound. You end up with a different compound and a different element. So do you see how, this time, that goes in and kicks out the negative part. It's a single displacement. Okay, for a single displacement, you got to decide, will it go? Okay, we don't have an activity series, but we have a built-in activity series. If you look up here at the 7A family, also called what? Halogens. That is an activity series for those negative ions. And those are the only negative ions we're going to mess with. So that means fluorine is the most active, chlorine is next, and it decreases. So we use it the same way. Fluorine will displace anything below it, kick it out. Chlorine will displace everybody but fluorine. Fluorine is very, very, very reactive. I heard a speaker once, he had lost a hand to a fluorine experiment. I mean, he was working with fluorine and it started going a little too fast, he had an explosion and he lost his hand. But he was so good with his artificial hand. I mean, it was a claw-like thing that he could control the little things. he gave a talk, and just for effect, this was back in the days you could smoke anywhere. Okay, he whips out a cigarette and strikes a match with his artificial hand and lit a cigarette, just to let you know that he was not handicapped by that at all. He could do anything. Now, he was killing his lungs by showing off, but anyway, fluorine, that'll help you remember. You can lose a hand to fluorine. It's the most active. So, this one right here, will it go? Yeah, because bromine is more active than iodine. So I went ahead and showed that it would go. But if I changed it and put I2 here and BR here, won't go. Won't go. And so this is a single displacement. Single displacements, you predict your products and you decide if it's going to go.